Sorry about the previous video. I was recording and then all of a sudden my computer just shut itself off. So where were we? We were here, and if you were to read the proof yourself, that would be here in the text. So we were currently here in the previous video. Now, if you look back at this, we started out with this, and then we incorporated a true definition of a limit. Well, if you look at the diagram, for a limit to exist, then it must fall within this band here. Well, this is your limit here, and remember your limit plus a small tolerance. So this level here. So here you've got your 0 and then 1, and then this is your limit here, rho. And then you can always select an epsilon, a small epsilon, where this here is rho plus epsilon. We can call this R if you want, R. And then now you've got a sequence, now you've got a series where it's going to be like this. N equals 1, and then you see this is a geometric series, and R is less than 1. So going back to here, hang on. So we were currently here, and then AN is always less than. We're going to say this to be R. Okay. So remember, 0, 1. And then if you have a geometric series where it's less than 1, you know it's going to converge. But then this is our limit here, rho, and then we're going to deliberately select a small number, epsilon. So this level here will be rho plus a small number, epsilon. So that's this level here. This number here, rho plus epsilon, is between the limit and 1. Between the limit and 1, somewhere between limit and 1. So we can call this R if we want to. So here you've got AN is always less than R to the power of N. And then if you're trying to sum up everything, AN here, and then you sum up all the RN here, but then this is a geometric series where R is less than 1. So you know this is going to converge. Well, and then this thing here being always bigger than this thing here, this will have no choice but to also converge. Remember, right from the start of the previous video, we demanded that AN to be positive. So if this thing here is going to converge, and it's always greater than this thing here, then this will have no choice but to also to converge. So this thing here, so hang on. So when you get to this stage here, in your mind, imagine this, 0, 1. It has a limit of rho, and then choose a number, choose an epsilon, where rho plus epsilon is somewhere between rho and 1. So this is your R here. So picture this in your mind when you get to this stage here. Okay, so what that means is beyond M, for all n beyond M, then it will be true. Prior to that, we cannot be sure that it's true, but definitely beyond capital M, it will be true. So going back to here, so we were here earlier. So beyond M, this would be true. This will converge. But prior to that, we don't know. But who cares? Because prior to that, let's say this is the number 17, and the next one is the number 15. Next one is number, I don't know, 7. Next one is number 3. You see finite, and then you're going to add another finite. Therefore, the whole thing is going to be finite. Basically, this thing here will converge. Okay? Yeah, that's the end.